We're talking about homework 7, number 1. I had asked you to estimate, right, the area under the sine curve. From 0 to pi using 6 rectangles. Now we had done this area from 0 to pi of sine x dx, and we got 2, right? And we remember how to do that, right? What's the antiderivative of sine x? What's the antiderivative of sine x? Negative cos x. And we're evaluating at pi, evaluating at 0, and subtracting them, right? Evaluating at pi, evaluating at 0, and subtracting them. Yes? So I get cos of pi is -1, and cos of 0 is 1. So there's my value of 2. And I think when we did it with 4 rectangles, I kind of remember we got, anybody have that in their notes? When I estimated the area of sine from 0 to pi with 4 rectangles, about 1.85, was it? Anybody have it? Probably last Tuesday or Thursday. $1.9, thank you. But today we should get a better estimate, right? Because we're looking at that sine curve, right, from 0 to pi, but we're going to cut it into 6 rectangles, 6 partitions, right? And from the right edge of each of those partitions, I draw up to the curve and draw my rectangle, right? So I got those 6 rectangles, and you can see the pieces that are missing are a little bit less, right? That piece from the curve that's missing is a little bit less than last time. I need to find, so I know this area is, this approximated area is equal to the sum from I equals 1 to 6 of f of x sub I times delta x, right? And delta x for me is got to be b minus a, so pi minus 0 over 6. So it's a pi over 6. The width of each rectangle is pi over 6. Makes sense, right? Because there are 6 rectangles, and it goes from 0 to pi, right? So the x sub i's are 0 plus delta x times I, so just pi I over 6. So meaning 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So that first rectangle is the right hand side is pi over 6, and the height is sine of pi over 6, right? So we get that coordinate pi over 6 comma sine of pi over 6 is that point. So our area turns out to be the sum of I equals 1 to 6, right? I is the counter of the rectangles, the first rectangle, the second. Sine of pi I over 6 times pi over 6, right? The height of the rectangle times the base of the rectangle. So I can just factor out that pi over 6 and put in my values of sine of pi I over 6. So meaning sine of pi over 6 plus sine of 2 pi over 6 plus sine of 3 pi over 6 plus sine of 4 pi over 6 plus sine of 5 pi over 6 plus sine of 6 pi over 6. And we know the value of sine of pi over 6 is it's 1/2. Sine of 2 pi over 6 is pi over 3. That's rad 3 over 2. Sine of pi over 2 is 1, right? 3 pi over 6 is pi over 2. Sine of 4 pi over 6 is another, that's 2 pi over 3. That's another rad 3 over 2. Sine of 5 pi over 6 is another 1/2, and sine of 6 pi over 6 is sine of pi, that's 0. It looks like I could factor out a 2 from downstairs. I get 1 plus rad 3 plus 2 plus rad 3 plus 1. Right, I factored out the denominator of 2. If there's no denominator there, I got to multiply the numerator by 2. So I get a nice final answer here of 4 plus 2 rad 3. Oh, I guess I could take out a 2, right? I get 2 plus rad 3. Oops, sorry, that's a 12. So I get pi over 6 times 2 plus rad 3. And then to the calculator. Second pi divided by 6 times parenthesis 2 plus square root of 3. 1.954. So closer to 2 than what we got when we did 4 rectangles. And of course, ultimately, when we go to an infinite number of rectangles, we get exactly the area of 2. So the first question on your second midterm is absolute min and max, right? So right now we're looking at midterm 2. Abs min and max. That's one problem from 4.2. One problem from first F prime test. One problem from F double prime test. That's 4.3 each of those. You're going to have a min distance problem from 4.6. You're going to have an estimate area that's 5.1. You're going to have the left-hand side, right-hand side. We'll do one like that next. That's homework 7, number 2. That's 5.1 to 3. And then you're going to have integrals. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's your midterm 2. And so we've gotten to step 3 of our integral checklist. We got to get up to step 12. Right? And that's all we're doing in the next few classes. And this is from 5.5. There's nothing on 5.4 on this test, which is the fundamental theorem of calculus, but I'm still going to talk about it. Okay? Yes? Yeah, to the problem? And I'll do that list again before the midterm. Okay? I'll do that list again. Brian, you need a picture of that list? Or this one? Yeah. Is that two? You want 2 pictures, maybe? Yeah. So there's your first picture. Got it? You got the second one? Travis, you need the second one? Yeah, you need the second one though? Yeah. Right there is good? Yep. And again, here's midterm 2. 10 problems, cut and dry, very simple. 2 hours to do it, right? So 120 minutes, 12 minutes a problem. Question? Yeah, second one again. Yep, absolutely. Right there, good? Yes. I always starts at 1 because you got to have a first rectangle. I is simply telling you first rectangle, second rectangle, third rectangle, right? To the midterm?
Yes.
Yes. I will do this over. I will do this midterm 2 list over. Once midterm 2 is done, I'll have grades up. I'll have your final exam prediction grades up, meaning what do you need on the final to get an A? And then I will create the list for the final exam. I'm going to cut things out of the final exam. So I can't test you on everything. Just not possible. I like 10 questions in an hour. So your final will be 10 questions. So I can't give you 10 questions from midterm 2, right? So I wouldn't give a first derivative and a second derivative on the final. I would do one of them, right? So, all right, let's do homework 7, problem 2. I had asked you for the integral from 1 to 5 of 1 minus x squared dx. And you can see why do I need to put that 1 minus x squared in parentheses? What's your opinion on that? I'm going to draw it over without, what's your opinion on why I need parentheses there? Yeah, you're welcome. Yeah, so I'm really trying to narrow in on what is the function you're integrating, right? And I would say in the one without parentheses, it looks like the 1 is related to the integral, and the x squared is related to the dx. You see what I'm saying? But I want everything related to the integral dx because it's one of these operators that's bookend operator. I need the left side and the right side of the operator. Not that important, it's just little subtleties like that. So we're going to show that this is equal to the limit as n goes to infinity of the sum of the first rectangle all the way to the last rectangle of f of x sub I delta x. So you're going to do this problem 3 ways. You're going to get it right with the calculator, you're going to get it right with the definite integral, and most likely you're going to make a little mistake on the right hand side. And so you got to make sure you don't panic. You can look at it, but most likely you won't see the mistake. Like when I was married, I couldn't tell it was a mistake until after the divorce. You see it afterward, right? So you can look at it. If you see a mistake, great. Most likely you won't. So you finish the rest of the test, and then you go back with a brand new piece of paper and start it again, right? That's what's going to happen on your second midterm, okay? So let's do the calculator first. So I'm opening my calculator, so are you. And in my y equal, I'm clearing everything out, making sure nothing else is there, and I'm typing in my function 1 minus x squared. I don't need parentheses here because I'm just stating the function. If I was dividing this by something, I would need to wrap the 1 minus x squared in parentheses, right? So I want to zoom standard because I want to make sure I can see from 1 to 5 on the x-axis, right? And I know zoom standard goes from -10 to 10 on the x-axis. So I see the function, and I can see this answer, all this area is going to be underground. So I'm going to get a negative answer. And it just says the area is underground between the x-axis and the curve. So I hit second calculate, and I hit number 7 for the integral. And now it's prompting me for what's your lower limit. It was 1, hit enter. Go to 5, hit enter. And it's shading the area and giving me the final area, which is what, -37 1/3. -37 1/3. Yes, everyone who's driving along with me at home got the same answer? Yeah? So that's easy. Every time I ask you to do a definite integral, make sure you check it on the calculator. Now we do it, our left-hand side, our definite integral. And if you remember, I'm doing step 1. What did I take a derivative of to get 1? X. And then level 2, what's the power rule for x squared? I got to add 1 to the power, divide by the new power. I'm going to evaluate at 5, evaluate at 1. So I get x minus x cubed over 3. Evaluate it at 5, evaluate it at 1, subtract. So I get 5 minus 125 thirds minus 1 minus 1/3. Right? Evaluate at 5, evaluate at 1, subtract. So what do I get? 5 minus 125 over 3 minus 1 plus 1 over 3. So I get 4 minus 124 over 3. I got 12 over 3 minus 124 over 3. So I have what? Minus, help me, 112 over 3. No problem. 112 divided by 3, 37 and a third. Right? Left-hand side and calculator should match and they'll be easy. Right? Right-hand side, most likely, you'll be a little impatient or careless or going too fast and you'll make a little mistake. And then you won't be able to see it, finish the rest of the test, and then go back and do it again with a brand new piece of paper. Okay? Yes? Yes. Absolutely. So, Desmos is crazy. I really tried to get us a computer classroom so we could get rid of this little dinosaur calculator thing. So I start typing integral, int, and it gives me from 1 to 5 of parenthesis 1 minus x squared, close parenthesis dx, and there it is, negative 37.3. Pretty sick stuff. Very cool. Good, right-hand side. So we want to show negative 37.3 repeating is equal to that limit as n goes to infinity of the sum of the first rectangle to the last of f of x sub I times delta x. So we have to calculate all these little pieces. So delta x is 5 minus 1 all over n. Just waiting for my pen to come back to life. There we go. Which is 5 over n. X sub I is 1 plus 5 over n times I, or 1 plus 5i over n. Oh, 4, right? Sorry. 4, right? Nice. Nice. Teacher can't even subtract. 5 minus 1 is 4, right? Sorry. And probably the most difficult part is finding f of x sub I, right? So f of x sub I is 1 plus x sub I squared. So that's 1 plus x sub I squared, right? And what am I putting in there? 1 plus 4i over n. Oh, minus, right? Sorry. Minus 1 minus x squared, right? Jeez, Robert. One minus x squared, right? So I got to expand that out. If you need to do it this way, right? Meaning write out what you're foiling and use your arrows just like you did in Math 50 or Algebra 2 in high school, whatever the last algebra class you took. Right? We're foiling things out here, yes? But I'm just going to go right to the answer, which is 1 minus 1 plus 8i over n plus 16i squared over n squared. So, n squared. I said n squared, but I didn't write it, right? So once I distribute the negatives, the ones cancel and I get negative 8i over n minus 16i squared over n squared. So there's the height of my rectangle. That's the height of my rectangle. The base of my rectangle is 4 over n. So we're trying to show that negative 37 1/3 is equal to the limit as n goes to infinity of the sum from I equals 1 to n of negative 8i over n minus 16i squared over n squared times 4 over n times the delta times the width of each rectangle, right? We're trying to show that that is going to be true. My process, not that I would do this if I was doing it on my own, is going to be to expand everything out as much as I can till I get to single terms and then take the limit of that. If you want to take a more elegant approach, I don't blame you. But this is what I'm saying you should do until you get the hang of it, okay? So at this point I get lazy, so I start writing L for my limit and I start writing sigma for my sum, and I'm distributing the 4n in. So minus 32i over n squared minus 64i squared over n cubed. I'm going to split my sum into two pieces, right? If I'm adding all the a plus b's, it's the same as me adding all the a's and then adding all the b's, okay? So I'm looking at the limit of the sum of negative 32i over n squared plus the sum of negative 64i squared over n cubed. So I split up the sigma, split up the sums. I know my sum is dependent upon the variable I, so everything else can be factored out of the sum. So I'm looking at the limit of negative 32 over n squared times the sum of I minus 64 over n cubed times the sum of I squared. The only thing the sum is dependent upon is the variable I. Everything else can be treated like you're factoring out of the sum. Now we have a formula for the sum of I, and we have a formula for the sum of I squared. So we're looking at the limit of negative 32 over n squared times n plus 1 all over 2, and minus 64 over n cubed times n plus 1 times 2n plus 1 all over 6. I want to cancel and distribute as much as I can. So I see that my 32 and my 2 cancel to 16. My n and my n squared cancel to n. Over here, the n and the n cubed cancel to n squared, and the 64 and the 6 cancel to 32 over 3. And I'm going to FOIL. So I've got the limit of negative 16 over n times an n plus 1 minus 32 over 3 over n squared times 2n squared plus 3n plus 1. And now I'm going to distribute. So minus 16n over n minus 16 over n minus 32 over 3 over n squared times a 2n squared minus 96 over 3 times n over n squared, and then minus 32 over 3 over n squared. Now these n's cancel, these n squareds cancel, and everything else is going to have some factor of n left in the denominator. So when I take my limit, all those pieces go to what number? 0, right? 96 over 3 divided by 1 billion. It's getting closer and closer to 0, right? So the only thing I have answer-wise left is negative 16 minus 64 over 3, right? The other pieces are zeros. So I have a minus 48 over 3 minus 64 over 3, which is negative 112 over 3, which is negative 37 1/3. Done. Why don't we take a 10-minute break and we'll come back. So we'll come back at 5 after 10.